I'm going to start off this video with a simple question. What factors help you decide what to wear to school? So, you wake up, you get out of bed, you go to your closet, how do you decide what clothes to put on? Maybe you go online to check the weather or look out the window to decide. Or maybe you have gym and you have to wear sweatpants and sneakers. Maybe you have a group presentation in one of your classes, so you have to look more professional than usual. Or maybe it happens to be picture day and you have to wear your best outfit. No matter what, the clothes you put on in the morning depends on all of these factors. Now, let's look at a simple example of two variables that have an effect on one another. Let's say you and your friend decide to start a lemonade stand right outside of your front door. After some disagreement, you decide that you want to sell each cup of lemonade for 50 cents each. This table shows the relationship between the number of cups you and your friend sell and the total amount of money that the two of you make. So, if you sell 0 cups of lemonade, you'll make $0. If you sell 1 cup of lemonade, you'll make 50 cents, 2 cups, $1, and so on and so forth. Do you see any relationships between the two columns? Without using any numerical values, it is clear that the more cups of lemonade you sell, the more money you and your friend will make. The less cups of lemonade you sell, the less total amount of money you will make. Now, let's try to find a more specific relationship. Notice that if we multiply 0.5 by the number of cups sold, you will get the total amount of money made. So, if you sell 0 cups, multiply it by 0.5, you get 0. 1 times 0.5 is 0.5. 2 times 0.5 is 1. If you notice, this simple computation works for every single value in the table. We can now write this relationship in words. So, the total amount of money that you and your friend make equals 0.50, or 50 cents, times the number of cups you sell. From this example, we can now understand very important definitions. Since the total amount of money you make is dependent on the number of cups sold, we can call the total amount of money you make the dependent variable in this situation. Since the number of cups you sell is not dependent on anything else, we call that variable the independent variable. Now, although a table is very useful to help us understand independent and dependent variables, graphing also helps in this situation. First, when graphing independent and dependent variables, there is one very important rule. The independent variable always goes on the x-axis, and the dependent variable always goes on the y. This way, we can easily see the relationship between the two. In this case, we have the number of cups of lemonade sold on the x-axis and the amount of money you make on the y. Now, using the values from our table earlier, we can graph the various points. So, we already know that if you sell 0 cups, you make $0, so you can plot that point at 0, 0. If you sell 1 cup, you make 50 cents, which is right there. 2 cups, you make $1. 3 cups, $1.50. 4 cups, $2. 5 cups, $2.50, and 6 cups is $3. Now, as we said before, the more cups you sell, the more money you make. So, we know that this goes on forever. So, I'm able to connect all these points and draw an arrow at the end. So, what does this graph tell us? Well, we learned before that the equation of a line is y equals mx plus b, where y and x are the variables we already discussed, m is the slope, and b is the y-intercept. We know that to find the slope of a line, we can simply do rise over run. So I decided to pick the two easiest points, which are 0, 0, right there, and 1.5, which is about right there. So in this case, the rise, well, we have y equals, and then the rise is 0 to 0.5, so it's just 0.5, and the run is 1. So now we have y equals 0.5 over 1x, plus, now b, as I said, is the y-intercept. And we can see from our graph that the y-intercept is 0 because that's where our graph hits the y-axis. So we have plus 0. So when we simplify everything, we get that the equation of this line is y equals 0.5x. If you remember the equation we got from the table, this is equivalent to the equation we just got for the graph, except using variables instead of words. So, what does this show? It shows that you can use a table or a graph to understand the difference between independent and dependent variables. Let's look at another example. This table shows the relationship between the number of hours Joe studied to the grade that he received on his test. So, we see here that if Joe studies for 0 hours, he'll get a 75 on the test. If he studies for 0.5 of an hour or a half hour, he'll get an 80 on his test. In this case, which variable is the independent variable and which is the dependent? Since Joe's grade on his test depends on how many hours he studies, we can see that his grade is the dependent variable and the number of hours he studies is the independent variable. Now, how would you go about filling out the rest of the table? You might realize that his grade keeps going up by 5 points for every half hour he studies. So then we'll get 85, 90, 95, and 100. But now, what is the more specific equation that can be used to discuss this table? After some guess and check, you can see that the relationship between these two variables is that his grade will equal the number of hours he studies times 10, that quantity, plus 75. Now, sometimes it can be very difficult to find this relationship. So it is very important that you check to make sure that this relationship works for every single value in the table. For example, you might look at the first value and think, oh, it's just the number of hours he studies plus 75, because that works for the first row of the column. But clearly that does not work for the second value of the column, so that is a very common error that you have to be aware of. Now, one of the cool things about independent and dependent variables is that you can use the equations you get to solve for the different values. For example, as before when we graphed, we're going to let y and x be our variables for the variables we talked about before. So we're going to let y equal the grade that Joe gets on his test, and we're going to let x equal the number of hours he studies. So, as I said before, the equation that works for this set of values is y equals 10x plus 75, whereas I said y equals the grade and x equals the number of hours. So let's say we know that Joe got an 100% on his test. How can we find out how many hours he studied for? Well, we can just plug in the specific values into our equation. So, since 100 is the grade, we have 100 equals 10 times x plus 75. So now we can just simply solve the equation. So, you can subtract 75 from each side. So 100 minus 75 is 25. So you get 25 equals 10x. Then, dividing 10 by each side, you get x equals 2.5. So, what does this tell us? This tells us that if Joe gets 100% on his test, that means he studied for 2.5 hours. Now, let's try to do this problem the other way. So we're still going to have y equal the grade and x equal the number of hours. But let's say we know that Joe studied for 1.5 hours. What grade will he get on the test? So we plug 1.5 in for x, so we get y equals 10 times 1.5 plus 75. We computate 10 times 1.5 and get 15. So we're left with y equals 15 plus 75, which is then 90. So this tells us that if Joe studies for 1.5 hours, he will receive a 90 on his test. Independent and dependent variables are around our world every single day, but it is very important to understand the differences between them. By definition, an independent variable is a variable whose variation does not depend on that of another, while a dependent variable is a variable whose value depends on that of another. In my beginning example, which variable would be dependent? By the definition that I just said, it is clear that what you wear is dependent on all of those other factors. So, I hope this video informed you a lot about the differences between independent and dependent variables, and just remember that you could always use graphs and tables and equations in order to learn more.